Okay. Now let us start the revision. Of course, the important definitions that in front of you. Okay, you have to memorize that definitions. It's okay. And then this is question one. Just I give you 1 minute to think of question one before to start to solve. Start, please. Use your pen and start to solve the question number. Okay, what is the meant by saying that electrical current equals 5 ampere? It means 5 coulomb of a charge pass through a point in 1 second. So we write it means 5 coulomb of a charge of charge pass through a point in just 1 second. How does the cross-section area affect the resistance of any material? We know that the resistance is proportional inversely to the cross-section area. So when the area increases, the resistance decreases. So we write when the cross-section area increases, just a minute, this down. When the cross-section area increases, the resistance decreases. Because the resistance proportional inversely to the cross-section area. Now, next question. A wire carries a steady current of 2 ampere. How many electrons pass through the wire in 2 hours? We have the formula that Q equals N capital multiply E. So the number of electrons pass through the wire in 2 seconds equals the charge in 2 seconds divided by the charge of electron. So to solve this question, we need to find the charge in 2 seconds. So Q in 2 seconds equals I multiply the time, which is 2. It's 2 multiply 2 equals 4 coulomb. This is the charge in 2 seconds. Then the number of electrons pass through the wire in 2 seconds equals 4 divided by the charge of 1 electron, which is constant, 1.6 times 10 power negative 19. Use your calculator to get the answer. The answer will be 2.5 multiplied by 10 to the power 19 electrons. Remember, the power must be positive because it is a whole number. So the power must be positive. Okay? So if you did mistake in calculation and the power, your answer was negative, it means wrong. The power must be positive. Now, next question. Look at this, please. The graph opposite showed the current I against the drift velocity V for electrons drifting in copper wire of cross-section area 0.25 millimeter square. Think of the question, please. First step, to get the drift velocity, we have to remember the formula. What is the drift velocity, or the rule of drift velocity? I equals N A E V. If we need to get N, rearrange the formula. So N, the number of free electrons per meter cube, equals I, the current, over A E V. I is the current in ampere, A is the cross-section area in meter, E is the charge of electron, V is the drift velocity. From the figure, we can deduce that when the current is 1.6 ampere, the corresponding drift velocity, because it's a direct relation, is 4. But remember, it's a 4 multiplied by 10 power negative 4. We write this given. So when the current equals 1.6 ampere, the drift velocity equals 4 multiplied 10 power negative 4 meter per second. Already this is a given from the graph. Also, the given is the cross-section area, but it is in millimeter square. We have to convert to meter squared multiplied by 10 to the power negative 6. So the cross-section area equals 0.25 millimeter squared. Okay? So it is 0.25 multiply 10 power negative 6 to be in meter squared. Now we can get the number of electrons. So we write N equals I over, this is the formula, AEV. So it's equals, I is the current, 1.6, divided by 0.25, multiply 10 power negative 6, multiply E, 1.6 times the 10 power negative 19, multiply the drift velocity, which is 4, multiply 10 to the power negative 4. When you calculate this, the answer is 1 multiply 10 to the power 29 electrons per meter cube, or we can write meter to the power negative 3. It means per meter cube. Next question. Try to think of the next question, please. Yeah. What will be, will the current if the drift velocity equals 8? In that question, you have two ways to solve. First way is a long way, just return back and use the same given for the drift, for the current, the area, and the other things. But the second way is shorter. We know that from the graph, the drift velocity is proportional to the current. So starting from this, the drift velocity proportional directly to the current. From this relation, we can say that V1 over V2 equals I1 over I2. Now, already from the graph, we have V1 or NEV from the graph. We said when the velocity is 4 times 10 to the power negative 4, 4 times 10 to the power negative 4, the corresponding current was 1.6. Now, we need the current, so we need I2. If the drift velocity is 8, multiply 10 to the power negative 4. From this formula, we do cross multiplication to get the value of the corresponding current. We can cancel 10 power negative 4 with 10 power negative 4 to simplify the calculations. Then, from this relation, we can say that I2 equals 1.6 multiplied by 8 divided by 4. So the answer be 3.2 ampere. Okay. Look at this question, please. Derive for conductor carrying current or conductor, I equals ANVE where n is the number density. Let us derive this. So the answer of this part, it's the derivative. We say for a volume of conductor V, it is the cross-section area multiply the length. The total charge in that volume, total charge in that volume, equals N E A L. This is the total charge. So Q equals N E A L. Let this equation number one. We know that the speed or the velocity denoted by V equals the distance over the time. The distance is the length of the wire and the time is t. From this equation, we can rearrange it to get the time. So the time equals L, the length of the conductor, over V. This equation number two. I is the current, which is Q over T. Q from equation number one, it's N E A L. Over T, it's L over V. From this fraction, we can simplify, cancel L with L, and move V upwards. Then we will get this formula. I equals N A E V. So this is a derivative, okay? So just memorize. Okay, guys? Right. Now, next step. Next question, sorry. Now, try to solve that question, please. I give you 1 minute to solve. Ready? Okay. The question is that in the diagram opposite show the electrical circuit indicate with an arrow, just one arrow, on the circuit, the direction of flow of electrons. Remember, the flow of electron is opposite to the flow of conventional current. So the electron flow, it's from negative to positive. So this arrow represents the direction of electron flow. So this is electron flow. Now, in part B, it said calculate the charge flow through the filament lamp over time 300 seconds. What are the givens? The given is that 60 milliampere. So the current is given, which is 60 milliampere. We convert it to ampere, multiply by 10 to the power negative 3. And we have the time. The time is 300 seconds. What is the required charge? Charge Q. So the charge Q equals I multiply T. This is the formula that we need to use. So the charge equals, the current is 60, multiply 10 to the power negative 3, multiply the time, which is 300. The answer will be 18, and remember the unit coulomb. Now, someone asked me something in the chat here. Clockwise, yeah. You can say clockwise, yeah, that's correct. We accept this solution. But he said in the question, indicate with arrow. Okay, yeah. Now, next question. Try to solve that. I give you 1 minute to solve. Are you ready? How can you read the question in physics? Yeah. Follow me, please. We read the question. Uniform copper wire of 1 meter length. Then we have the given L. The length of the wire in meter is 1. With cross-section area, this is A. A equals 5 multiply 10 power negative 7 meters squared. And the electron number density, this is N small, the number of free electrons per meter cube, which is 8 multiply 10 to the power 28 per meter cube. Carries a current 1 ampere. So this is I, it's 1 ampere. Calculate the mean drift velocity. Actually, we say the mean because it's million of electrons. So the drift velocity V equals I over ANE. The order is not important. You can say NAE, no problem. Now, we do substitution. The current is 1. The cross-section area is 5 multiply 10 power negative 7. N is 8 multiply 10 power 28. E is the charge of electron, 1.6 times the 10 power negative 19. Use your calculator. When you use your calculator, the answer becomes 1.56 multiply 10 to the power negative 4 meter per second. Okay, now, next question. How much time is needed for an electron to move from one end of the wire to the other? The length of the wire, this is the wire. The length is 1 meter. So the distance or the length of the wire is 1 meter. We need the time. Which formula we use it? We use that V, the velocity, equals the distance over the time. So V equals the length of the wire over the time. Rearrange the equation. So the time needed equal the length of the wire divided by V. Which V? Drift velocity that we got it before. The length of the wire, 1 meter. The drift velocity, 1.56 multiply 10 power negative 4. When you use your calculator, the answer is 6.40 multiply 10 to the power 3. Okay. Okay, this is the time, 10 to the power 3. So what is the unit here? It is second. The time in second. Just I see the question here. For chat. Yes, meter. Oh. Okay. Yeah. This is the answer, okay? Yeah. So the time, that is the time. It's okay, 6.40 times 10 power 3 seconds. Okay, is it clear? Now, next question. Read the question, be careful, and try to solve. I give you 2 minutes to solve the question. Okay, let us resolve the question. The current voltage, so this is IV. Now, remember the formula of Ohm's law? This is the formula of Ohm's. V equals I times R. Then R equals V over I. But this graph is I over V, or IV, sorry. Then the resistance equals 1 over the slope, because it's IV graph. It said calculate the resistance of the wire at each temperature. Now, the first wire, L1, okay, we find the slope. For L1 or T1, we can use this one. It's okay? Here. The current is 0.8 and the voltage is 8. So the slope is the vertical change, 0.8, over the horizontal change, which is 0.1. R1 equals 1 over the slope. So it's 1 over 0.1 will be 10 ohms. The same way in L2. The second is the slope 2. For L2, we can take the same point, 0.8, but the voltage is 4. So the vertical change is 0.8 and the horizontal change is 4. So it is 0.2. R2, the resistance of the second line, 1 over the slope, it's 1 over 0.2. So the answer is 5 ohms. Now, which is higher temperature? We know that for the metal wire, when the temperature increases, the resistance increases. So the temperature of higher, so the wire of higher temperature, that it has greatest resistance. Because when, okay, T, the temperature increases, the resistance also increases. Now, T1 is higher temperature, is higher temperature. Why? Than, of course, than T2. Why? Because R1 is greater than R2. So this is the reason. Because R1 is greater than R2. Yes, I show here question. Yes, Mister, for the first question, can we just write 5 ampere is 5 coulomb second? No, you have to explain. You have to say 5 coulomb, but through the point in 1 second. No, don't write this, please. Okay, thank you. Now, next question, question number 6. Remember, I will send this file as a PDF after the lesson. So don't worry, just use your hand and the pen to solve. Start to solve the question number 6, please. Welcome. We read the question. A bulb rated at 2.5 watt and 3 volt. So for the bulb, just for this bulb, not for the whole circuit, the power equals 2.5 watt when the voltage is 3 volt. The battery potential difference is 9 volt. Calculate the current through the bulb. It's easy to get the current through the bulb. Which formula? We know that the power B equals I multiplied by B. Then the current equal the power divided by the voltage. So the power equals, okay, 2.5 divided by 3. The answer is 0.83 ampere. Finished. Find R. Now, to get R, we need the voltage because this is Ohm's law. V equals I times R. So to calculate R, we must have the voltage and the current. The current, it is the same because it is series connection. Then we have here the current in the circuit. So the current through R, it is the same as through the bulb. The current is 0.83 ampere. But we need to get the voltage through the resistance R. But already we have the voltage through the bulb. Okay, so the voltage through the bulb, okay, already given 3. So the first step, we calculate the voltage through the resistance R. It is the total voltage minus the voltage of the bulb, because it is just two instruments or two things, bulb and resistance. Both of them take 9 volt from the power supply. So 9 volt minus 3 volt that dissipated in the bulb. So the rest will be 6 volt. So 6 volt, this is the voltage in the resistance. And the current in the resistance, it is the same as the whole circuit, which is 0.83 ampere. Then we can get the resistance. R equals V over I. V equals 6 over 0.83. When you use the calculator, it will be 7.23 ohms. Yes, question? Yeah. R equals 17.2? No. It is 7.2, not 17. Okay, yeah, it's correct. Now, next question about the total resistance. I give you 1 minute to write this one. Write 3 factors that affect on the resistance of metal wire. Of course, there are 4 factors. Only 3 enough. I will write for you the 4 factors. Try to remember the 4 factors with me. Number 1, the length of the wire. The length of the wire. Number 2, the cross-section area. Sectional area, of course, of the wire. Number 3, the material of the wire or resistivity. Material. Okay, material of the wire. Last thing, number 4, temperature. Okay, any 3 of them acceptable. Calculate the total resistance. Try to think of this question. Calculate the total resistance. Okay. Yeah. Okay. Okay. Now, how can we calculate the total resistance? First of all, we divide the circuit into parts that 3 and 6, they are connected in parallel. So 1/3 plus 1/6, all to the power -1. Okay? So we can get this by using the calculator. Fraction 1/3 plus fraction 1/6, close the bracket, to the power -1. The answer is 2. So we can replace that 2 resistors as a 1. So it's 2 ohms. So we replace that 2 resistors with 2 ohms. And then 2 plus 4, they are 6. But we have to write the steps because this question has 3 marks. So it's better to write the ways like this. So R 3 and 6 equals 1/3 plus 1/6, all to the power -1 equals 2. And then the total, okay? So R 4, 3, and 6, they are series, so we add 4 plus 2 equals 6 ohms. So all the branch, the upper branch is 6 ohm, Then R 4, 3, 6, and 6 down. They are in parallel, so it's 1 over 6 plus 1 over 6 all to the power -1, which is 3 ohms. Then for the whole circuit, so R total equals 9 plus 3 equals 12 ohms. So this easy question, but try to concentrate. Calculate the potential difference across 9 ohm. To calculate the potential difference across 9 ohm, we need the current. The current, it is the current of the circuit. So we find I total. So the total current in the circuit. I total equals V total from the battery over R total. V total is 6 and R total is 12. So the current is 0.5 ampere. Now, the potential difference across 9 ohm, it is I multiply R. I is the current from the source, the main current, multiply the resistance, which is 9. So the answer is 4.5 volt. Okay, guys? Yes. Mister, is it okay if we are not sure the answer? We will write all 4. What do you mean by write all 4? 6 over 9? I think no, because actually, no. Because actually, okay, but I think in the exam you have to clear your answer. This is the way in the correction, in the final exam. Okay, now, next question. Question number 8. Ready? Start, please, to solve. The factors that affect resistance. I explained the factors. Yeah. Now, find here the potential, define the potential difference. Okay, already I gave you the definition at the beginning. Okay, direct, okay. Here, the potential difference, it is the energy, because actually we have to write the solution here to be guide for you. So it is the energy per unit charge as charge moves from point to another. From point to another. Now, resistance, it is the ratio of potential difference to the current. Ratio of potential difference to the current. Yes, question? Yeah, not 12. I don't get your idea. Yahya, I think.
Above, Mr. You wrote instead of 12, I mean 6 divided by 12, you wrote, I mean 6 divided by 12 instead of 6 divided by 9.
6 over V total here. V total is 6 over R total 12 is 0.5. And IR, this is the current here, multiply the resistance. The resistance is 9 and the current, it's correct. Correct. The answer is correct.
Teacher, he means
Okay,
in current. He means in current. He asked for 9 resistance.
For 9 resistance? Which part?
Must be 6 over 9.
Part D, Mr.
6 over 9. R2 6 over 9, not 12, but R total, calculate the potential difference, yeah. But here, I total, Yahya, it is 6 over R total. R total include 9 and 3, not 6 over 9. 6 over 9 is wrong. Okay, so this is correct answer. Yeah. Okay, now next question, calculate the internal resistance R of the battery. Think of that question, please, because it's little hard. What is the formula that we can use here? First of all, we have to check the given. What are the givens in this part for the internal resistance? 10, of course, it is the external voltage, okay? Or the terminal voltage. It's a 10 volt. And the 12 volt is EMF. Okay? And also the current here in the circuit, it's a 2 ampere. From that three givens, we can get the internal resistance. Which formula we use it? E equals V plus IR. So we can calculate R. Okay, then we write here E equals V plus IR. We do substitution. V equals 12. Okay, terminal voltage is 10. Current is 2. Multiply R small. When you rearrange 12 minus 10 equals 2, so 2 equals 2R, then the resistance, the internal resistance equals 2 divided by 2, it's 1 ohm. Find the value of R2. Now, we need to get R2. Here, at this junction here, this is a junction, okay? The current in is I3, okay? But look, please, we can get the voltage through R3, it's better. This is V3. To get V3, because you have the current and the resistance. So you can get the potential difference across R3 by using the Ohm's law. V equals I times R. So you can get V. V equals I times R. So V3 equals I times R. What is the current passed through the resistance? Here, the current it's 2. The resistance is 3. 2 times 3, 6 volt. Now, the voltage through the parallel resistors, the total external voltage or the terminal voltage is 10, not 12. Then the voltage of R1 equal the voltage of R2 because they are in parallel equal the terminal voltage, which is 10 minus 6. So it's 4 volt. Now, we need to calculate R2. So to get R2, we need I2. How can we get I2? By using Kirchhoff's first law. The current in equals I1 plus I2. I, it's 2 ampere. I1 is 1.33 plus I2. So we can get I2 from this formula. So I2 equals 0. Okay, 2 minus, it is 0.67. 0.67 ampere. So we have the current and we have the voltage. So we can get the resistance. So the resistance R2 equal the voltage over what here? Okay, over the current. The voltage, it's 4 divided by the current, 0.67. So 4 divided by 0.67 equals 5.97 ohm. You can solve in another way, no problem, but this is the answer. Yes? Why we did not use 12 volt? 12 volt, it is the total, 12 volt, it is the EMF. But the terminal voltage is the voltage that we use outside. because we know that the EMF, it is the voltage of the battery when there is no current. But if there is current, EMF reduced to terminal voltage, because the EMF equals the terminal voltage plus IR, the lost voltage. The terminal voltage that we use in the circuit is 10 volt, not 12. Okay. Yes. Now we see next question. Start please to solve question number 9. I think it's easy question for you. Figure 1 shows a circuit containing two identical diodes, A and B. Remember, the diode allows the current to pass through in one direction, from positive to negative. Which diode is representing in figure 2? So it is forward, okay? Which one is forward? Here, it's diode A, because this is the positive current, we can see here. So this is the positive current. So this is the direction of the current. So this forward, but this reverse. So this forward diode. So diode A is the correct answer, because allow the current to pass in one direction. Why? Because it is a forward biased diode. This is the reason. It is a forward biased diode. Find the potential difference across the diode when the current increases rapidly. Oh, increases rapidly here. At what? At 0.6. So the voltage is 0.6 volt. After this, the resistance will be very low. Okay, yeah. Okay. Next question. Question number 10. Think of question number 10, please. Sorry, because the lesson will be concentrated, because through the 2 hours, we need to finish the whole revision. Try to think of question number 10, please. The table below shows the voltage applied on some wires of different materials and their resistivities. The wires have the same dimension, so they have the same length and the same cross-section. Which material has highest resistance? Actually here, what is the relation between the resistance and the resistivity? We know that R equals rho L over A. When L and A are the same, are constant, then R proportional to rho. When L and A are constant. Okay, now we said which material has highest resistance? That material has highest resistivity. Okay, so which material has highest resistivity? You know that it is germanium. So this germanium has highest resistivity, so it has highest resistance. So the answer is germanium. Why? Because R proportional inversely to rho when L and A are constant. Find the current flow in gold. So this is the gold. The gold has what? Has resistivity. It's given in the table. It's 2.44 multiply 10 power negative 8. And it has voltage also. It's okay. V. V equals 8 volt. Also, we have given the length and the cross-section area. But the length in centimeter, 10 centimeter, so it means 0.1 meter. And the cross-section area, it's in meter squared, So 2 times 10 to the power -4 meters. First of all, we calculate the resistance. R equals rho L over A. We do substitution. Rho equals 2.44 multiply 10 to the power -8 multiply L is 0.1 over the cross-section area 10 power -4. So from this equation, the resistance by using calculator, it's 1.22 multiplied by 10 to the power -5 ohms. Now we can get the current. The current from Ohm's law, it's V over R. V is given in the table, it's 8 volt, and the R, we got it, 1.22 multiply 10 power -5. The answer by using calculator, it's a 5, it is 6.56 multiply 10 to the power 5, and the unit is ampere. Yes? Question? Yeah. Germanium? Yeah. Okay. Yes. Any other question? Yeah. It's okay? Very good. Okay. Now let us see the next question. Yeah. Go ahead, please. In this table below, compare between effects of increasing temperature on resistance of metal and the semiconductor. Try to solve it, please, and also solve the part B. Okay. Now, resistance of metal increases as the temperature increases. So in case of metal, increases. Okay. In case of semiconductor, decrease. Okay, the resistance decrease. Now, think with me of question part B. He said when 4 identical resistors are connected in series. So, with the power supply, the dissipated power is 25 watt. Okay? If they are connected in parallel with the same power supply, calculate the dissipated power. First of all, in series. Okay? What is R total? R total equals R plus R. Let the resistance is R. So it's R plus R plus R plus R because they are connected in series. So it's 4R. And the power here, okay, they said the power. So this is the total here, the total resistance, okay? Now, the power, okay, let this power denoted by B1. We use the formula V squared over R total. Okay, so V squared, we don't have V squared, over R total, it's 4R. The given is that it's 25. From this formula, we can get V squared over R. How? Multiply by 4 both sides. So multiply this side by 4 and also this side by 4. Then we can get this value. So V squared over R equals 25 times 4, it's 100. Now we go to the parallel connection. The parallel connection R total equals 1 over R plus 1 over R plus 1 over R plus 1 over R all to the power -1. 4 over R all to the power -1, flip it, so it's R over 4. They said they connected in with the same power, so calculate the dissipated power. Now we need B2. So in case of parallel, let it's B2, which is equal to V squared over R total in case of parallel. So it's V squared over R total is R over 4. Now we flip 4 up. So it's a 4 V squared over R. But V squared over R, we got it before, which was 100. Then it's 4 multiplied by 100 equals 400. The unit of power is what? Okay. Yes, question. Teacher, what are some semiconductors? Okay. Teacher, what are some semiconductors? What do you mean by that, Tariq? Example? I don't understand the question. In case of semiconductor, I said the resistance of semiconductor decreases as temperature increases. Why? Because the conductivity increases in case of semiconductor. Okay. Now, question number 12. Yes, still the question? Yeah. Okay, thank you. Now, question number 12. Start to solve, please, here. The figure below shows two circuits with identical resistors and the same EMF. But now, they are series connection, of course, both. If the dissipated power across the resistance circuit 1 is P1, what is the total dissipated power in circuit P2? In terms, we need the relation between P1 and P2. The same idea like before. So, in circuit 1, okay, what is R? Okay, in circuit 2, we start, it's better because it has two resistors. In circuit 2, R total equals R plus R, which is 2R. This is R total. And the power, in that case, is P1. So this is, it's P2, okay? But he said the dissipated power across the resistance, this is P2, it's okay? So the power in circuit 2 is P2. Now, what is the relation between the power and the resistance? Okay? Okay, the power and resistance. So B equals I times V. Because it is series connection, it is the same current. So the power, V squared over R. No, V squared over R, sorry. So we can use this better, not this. So the power equals B squared here over R. So the power equal V squared over R. The same EMF, can you see? The same EMF. So the same V, then the power proportional inversely to R. Then B1 over B2, B1 over B2 equals R total, okay, 2, R total 2 over R total 1. Now, for this one, B1 already, we need a relation between B1 and B2. So B1 is here. And for the second, it's 2R. And B2, the resistance of B2 related to the total resistance of the first circuit, it's R. Cancel R with R, so it's 2 over 1. Then B2 equals half B1. This is the formula. Okay. Now, next question. Yes. Question number 13. Start, please, to solve the question number 13. It said state Ohm's law. Ohm's law states that current in conductor, you have to say conductor, not semiconductor, is proportional to the potential difference across it at constant temperature. So we have very important words here. What are the important words? Conductor. If you don't write conductor, you will lose the mark of the question. And also you have to say constant temperature, and also the current proportional directly to the potential. Now, he said when the switch is closed, so when the switch is closed, the reading of voltmeter is 60. So this voltmeter is 60. It is not the terminal voltage. Calculate the resistance R. Now, from the voltage and the resistance, we can get the current in the circuit. Which formula? We know that I equals V over R. So from this formula, we get the current in the circuit. V is the voltage, which is 60 volt over 30. So the current is 2 ampere. Which formula, when we have the internal resistance, okay, we can say here EMF. Okay, so EMF equals I R plus R. What is R? R is the total external resistance. So it is the total external resistance. Now, EMF here, it's 120. And the current, it's 2. What about R external? External, we have 2 resistors connected in series. So we add them. So it's R plus 30. What is R internal? It's given, it's 2. From this, we can get R. So 120 equals 2 R plus 32. Distribute 2 over the bracket. So 120 equals 2 R plus 2 times 2, 4 times 3, 6, 64. Shift 64 to the other side equals 2 R. Then from this, we can get R. R equals 28 ohms. Okay, guys? Just we take a few minutes break for prayer time, and then I return back. Okay? Okay, guys, now question number 14. Question number 14 here, it's about Kirchhoff's law. Well, started to solve these. He said, state Kirchhoff's second law. Kirchhoff's second law states that around any closed loop, the sum of EMF equals the sum of potential difference. So we write here Kirchhoff's second law. We write sum of EMF, okay,
Teacher?
in a closed loop. Yes.
In that question, the answer is not 28.
The answer is not.
It must
Let
be
me-
28 divided by 2.
Which question? Previous question or this?
Yes, yes.
The previous question? 28
Yes,
divided by 2?
It must be, yes, 28 divided by 2.
No, my friend. 120 minus 64. Solve this. 120 minus 64 equals 56. So 56 equals 2R. I do it quickly. So we divide by 2 both sides because it's 2R.
Okay,
divide by 2. So it's 28.
Okay.
Don't worry. Don't worry.
Okay, okay.
Thank you for
Sorry.
that question. No, don't worry. Now, we return back here about the sum of EMF in a closed loop or in closed circle is equal to sum of potential differences. In that question, it said find the value or the values of E1 and E2. Now, first of all, at junction A, we have junction here. But at this junction, we have 2 currents away. First step, follow me. How can you solve the Kirchhoff's law question? Okay. First, we're starting with Kirchhoff's first law because it's easier. Follow me, please, here. This is the current here. This is the direction. So this is the direction of the current. So it's 1 ampere. And this is the direction here. It's 2 ampere. So the current in is 1 and the current out at junction A is 2. Then in this branch must be in because the current in 1 ampere less than the current out. So let the current in this branch is I. So we can get the value of I. How? Okay, we say at junction A, at junction A, the sum of current in, this is Kirchhoff's first law, the sum of current in is 1 equal, okay, plus I, that are the sum of currents in, equal the current out, it's 2. So I equals 2 minus 1 equals 1 ampere. So we got the current I in branch DA. Second step, put the direction of electron flow. The direction of electron flow, it is separate to the direction of the loop. So this is the direction of electron flow. It's from negative to positive. This is the direction of electron flow. This is the direction of electron flow. Now we choose the loop. You can write here loop 1. We take this. So this in the exam, you can draw this loop. So we say loop 1. Now, we start with a point. This is loop 1. So we can start with any point in the loop 1. We can start from the point B and go around the closed loop until you come back to the point A. Then we write here loop 1. I said I start from point B. I go in this direction. It's a clockwise direction. Can you see? Now, in case of resistance, it will be negative. So the current here, can you see? The current here, this is the current, direction of the current. Can you see? The current, it is in opposite to the direction of loop. If the current is opposite to direction of loop, we put more negative. The resistor will be negative. But because the direction of current is opposite to the direction of the loop, we put another negative. The current is 1 ampere and the resistor is 1 ohm. So it's 1 multiply 1. Also, the direction of loop is opposite to direction of electron flow. So it's a negative 20. Now, the current is 1 ampere and the resistor is 6. So also this is double negative. Why double negative? Because the current is opposite to the direction of loop. So 1 multiply 6. Then this is the direction of loop. So plus E1, because it is in the same direction of loop. Now, the direction of current in this branch here, so it's 1 negative, negative 1 multiply 1 ohm, and then negative 1 multiply 4, return back to the point B equals 0. From this, we can calculate E1. Let us do this together. Negative, negative, it's positive, minus 20, plus 6, minus 1, minus 4. So negative 18 plus E1 equals 0. From this, E1 equals 18 volt. Now, we use the second loop. We can see this loop. We can take this loop, loop 2, in this direction. Anyway, by the way, you will get the same answer. Now, I start from the point D, and I go in this direction of loop 2. So we write here loop 2. The electromotive force here, or E, electron flow, it is the same as the direction of loop. So it's a positive E1. Now, minus 1 multiply 1, minus 1 multiply 4, minus the current now 2, and the resistor is 1. So it's a negative 2 multiply 1 here. The direction of the loop is opposite to direction of electron flow. So it's minus E2, okay? Minus 2 multiply 2 equals 0. You can solve the Kirchhoff by any way, but this is my way. I think it's easier. Now we calculate E1. Already we got E1 before, so we replace it by 18. Minus 1 times 1, it's 1. Minus 4 times 1, minus 2 minus E2, minus 4 equals 0. Now we calculate this. 18 minus 1, minus 4, minus 2, minus 4, it's 7. So 7 minus E2 equals 0. Then E2 equals 7 volts. Okay, so this is a little hard question about Kirchhoff's law. Yes, question? Yes. Mr. Can the loop both have the same direction? Yes, of course, no problem. No problem. You will get the same answer, don't worry. Okay? Yeah. Now, look at this question, drive. This is the second drive in chapter 1 or in electricity. It said drive using Kirchhoff's laws, the formulae for combined resistance or resistors in series and parallel. Now I solve this question. So first, we talk about series. So we draw this circuit. This is R1, R2, R3, connected to power supply. Now, this is EMF, and this is V1, V2, and then this is V3. In series connection, the same current. Same current. Now, we write by using Kirchhoff's second law. You have to mention which law you will use. So in series, we use Kirchhoff's second law. We know that the sum of EMF equals the sum of potential difference. The sum of EMF is V total. It is from the source, V total, equals V1 plus V2 plus V3. But we know V equals I times R. So I times R total, because it is the same current in the circuit, so the current is the same. It's I, the same current. Okay? So we don't say I1, I2, I3. It is the same current I. Then V1 equals I multiply R1 plus I multiply R2 plus I multiply I3. Then we cancel I because it is the same, divide by I, both sides. We will get the total resistance in series. R total equals R1 plus R2 plus R3. Now, the second part in parallel, resistors in parallel. We draw resistors in parallel. This is R1 and this is R2, R3. They are connected in parallel. Okay. So this is connection. This is the junction. Connected the power supply. Yeah. In parallel, the voltage is the same. So it is the same voltage, the same potential difference. Now at junction A, here we have the current. So the current from the battery is I. it is okay, distributed into I1, I2, I3. Now we use what? We use Kirchhoff's first law. So by using Kirchhoff's first law, at junction A, the sum of current in equals the sum of current out. So I equals I1 plus I2 plus I3. From Ohm's law, V equals I times R. So I equals V over R. It is the same voltage V. So we don't say V1, V2, V3, but R, it's R total. I1, it's V over R1 plus V over R2 plus V over R3. We cancel V with V because it is the same and replace it by 1. Then this is the formula of resistors in parallel. 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over R3. Okay, but in calculations, we write here R total equals 1 over R1 plus 1 over R2 plus 1 over R3, all power negative 1. This relation is the same, but this is easier for calculation. Okay, this is the second derivative. Now, question number 15, start to solve. Sorry, I go quickly to finish on time, please. Yeah, go ahead, please. Calculate the value of I1 and I3. Okay, guys. Try to solve, and I help you. Try. Ready, Shala? Okay, ready? Now, we said calculate I1, I, and I3. Okay. We're starting at junction D. The sum of current in equals the sum of current out. So at junction D, this is Kirchhoff first because it's easier than Kirchhoff second. Current in is I2, and the current out is I1, and the current out also I3. So this is I1, and this is I3. So I2, the current in, equals I1 plus I2. I2 equals 4.8, so I1 plus I3, sorry, I1 plus I3 equals 4.8. Let this equation number 1. Now, we use the loop. Now let us take this loop, say loop 1. Now we put the direction of electron flow. It's from negative to positive. This is the direction of electron flow. We start from any point. For example, we can start from the point A. So here it's 10 volt. Okay. The current is I1 and the resistor is 4. So negative 4 I1. And here, this is the direction, this is I2. And this is the direction of loop. So we write negative 2 I2 plus 15 equals 0. I2 is given 4.8, so 10 minus 4 I1 minus 2 multiply 4.8 plus 15 equals 0. Let us solve this by using calculator. So 10 minus 2 multiply 4.8 plus 15 equals, okay, here, 15.4. So 15.4 minus 4 I1 equals 0. From this, we can get I1. It's 15.4 divided by 4. So divided by 4. The answer is here 3.85. Now, from equation number 1, I1 is 3.85 plus I3 equals 4.8. Then we can get I3. It's 4.8 minus 3.85. 4.8 minus the answer. So it is 0.95. 0.95 ampere. In the second part, he said, find the potential difference between B and C. Where is B and C here? Between B and C. So we need the voltage. V equals I times R. What is the current in that branch in PC? It's I2. Multiply the resistance. R equals 2. So it is I2 that we got it. I2 or I2, it's okay. It is 4.8. So the potential difference, it's I2 multiply R. I2 is given 4.8 and the resistance is 2. So the potential difference is 9.6 volt. Okay, now, next question. Considering the transformation of energy, what is meant by the potential difference is 1 volt? It means 1 joule of electrical energy converted to heat and light, because they said bulb, for each 1 coulomb of a charge that passes through the bulb. We write this. So 1 joule of electrical energy converted to heat and light. And light for each 1 coulomb of charge. Okay, that passes through the bulb. That passes through the bulb. Actually, this is a knowledge question, so it has only 1 mark, not 2 marks. Okay? Now, next question. Question number 16. Yeah. Now, this is little hard question. Try to think of it, please. Okay. Yes, Mr. Is the lesson only for solving? What do you mean by for solving? You will solve and I explain also. This is just revision. Solving the question? Yes, because it's final revision. We solve a higher question, higher level questions. About what? About electricity. So we don't have any time to explain the topics, because just in one lesson, we explain 40% of the syllabus. Okay? There is no enough time now, because already you understood that topic, because I don't explain from the beginning of the topic. Just I go direct to review the hard questions about what? About electricity. Yeah. Now, try to think of question number 16. He said here, 2 batteries. Okay, can you see here? Okay, it is 2 batteries of negligible internal resistance, connected in series with 3 resistors, as shown in the figure. Resistor X has resistance 4, resistor Y has resistance 1.5. The resistor R of variable resistor is changed until the voltmeter circuit reads 0. Okay. So what do you mean by reads 0? 0, it means a balanced point. So here we can say this is a closed circuit, like this. So we can say this is A, B, C, D. So in that closed circuit, so in that closed loop, or in that part of the circuit, okay, in the part A, B, C, D, we know that the sum of EMF equals the sum of potential difference. So in that part of the circuit, just we have only EMF, which is 6 volt. What is the potential difference? Because they said the current, we need the current here. So this is the current. So the current potential difference is I times R. I is the current and the R is 4. Then from this relation, we can get the current. So the current equals 6/4, which is 1.5 ampere. خلاص. We need the resistance R. To talk about R, we use Kirchhoff's second law. Now we use that loop A, B, okay, E, F, the big loop. And also we go in this direction. This is the loop. So we write here loop, okay, just I minimize it. Okay, so we write loop A, B, E, F, A. Okay, now, yes, one question. Mister, I did not understand the circuit. Okay. Oh, circuit reads 0. It means the sum of EMF equals the sum potential difference around this part. Okay. So this means here the voltmeter reads 0. So in this part here, this is a closed loop. Okay. So just in that closed loop, we use this formula. It's okay. I know this is difficult part. Now, in the loop, yeah, yes, Mister, but there is a junction. No, there is no junction here. Which junction? No any junction here. It is just loops. This is just loop. Okay. When we say the potential difference equals 0, it means there is no current in the voltmeter. Okay. So just this is the way. Okay. No junction in that circuit. It's all closed circuits. Now, in A, B, E, F, A, we use Kirchhoff's second law. We can start from this point. Yes, question again? Yeah. Thank you. Thank you. Yeah. Now, the current now, already we got it. So it's negative because the resistor, okay, also the same way as we did before in Kirchhoff's first law, in Kirchhoff's second law. This is the direction of electron flow. Then negative I times R, sorry, we can do replace by the value direct to minimize the time. So the current we got it's 1.5. So negative because it's a resistor, negative 1.5 times 4 plus 6, and then minus 1.5 again times the current is 1.5 plus 6 minus R multiply 1.5 equal 0. Now we calculate the value of R from this. Use your calculator. Negative 1.5 multiplied by 4 plus 6 minus 1.5 multiply 1.5 plus 6 equal 15/4, 33.75 minus 1.5 R equals 0. Now, shift this to the other side, 3.75 equals 1.5 R. So R equals 3.75 divided by 1.5. The answer is 2.5 ohms. So this is the answer of this question. Okay. Now, next question, define the electric current. Try to solve this question, please. I give you 2 minutes to solve part A and then part B. Now, the electric current is what? Rate of flow of a charge past a point. Now, next step here. Here it said if the internal resistance is, so we have given here R small, 0.1 ohm. And from the graph, actually here, just a quick review about this graph. Here, this is the graph of V, and this is the current. So the line represented by this is the EMF, and the slope equals negative R. This comes from where? From this. E equals V plus V, or E equals IR plus IR small. Now, note that I equals E over R capital plus R small. And R small equals E minus V over I. We have here 3 important things about what? About I maximum. The maximum current equals E over R. This when R capital equals 0. And V maximum equals EMF. This when R small equals 0, or when the current equals 0. Finally, the maximum power when R capital equals R small. That are 3 important things about the internal resistance. In that question, what do we have here? We have here the internal resistance. This is R. It said calculate the maximum current. Now, this is the maximum current. I maximum equals the EMF over R. EMF from the graph is 1.6. Internal resistance, 0.1. 1.6 divided by 1 equals 16 ampere. Now, somebody asked me about, do we solve the questions? We solve and explain the important points, like this. If there is something need to revise with you, I will revise. Now, next question. Think of that question, please. Now, this is a little hard question. Okay, yeah. So try to think of that question, please. He said the figure below shows 3 equal resistance. Oh, equal resistance connected in parallel. So they have the same current because they are equal resistance. The current in one of the resistor, we can say this is R, and this is R, and this is R. The ammeter reading is 0.6. So the current in this R is 0.6 ampere. Also because the same resistance, it is 0.6. Also here 0.6. Then we can get the total current. So I total from the battery equals I1 plus I2 plus I3, which is 0.6 plus 0.6 plus 0.6. So it's 1.8 ampere. Now, we read the question. Is it connected to parallel to 5.75 battery? So this is the EMF of the battery. Now, the terminal potential difference is always less than the electromotive force. When the power supply delivers current, state the reason. Because lost voltage in the internal resistance. Okay, so we write here because of existence of potential difference across the internal resistance. The internal resistance, which is called what? Lost voltage. Okay, because the lost voltage. Now, remember E equals I, V capital plus I. Remember E equals V plus IR. So because the lost voltage E not equals V, it will be less. Now calculate the resistance R of each circuit. Now, we said I total here equals 0.6 plus 0.6 plus 0.6 equals 1.8 ampere. Which formula we use it in case of EMF? That EMF equals, okay, I, okay, R plus R. Now, what is R external? The external resistance is the three resistors in parallel. So it's 1 over R plus 1 over R plus 1 over R, all to the power -1. It's 3 over R, all power -1. It's R over 3. This is the external resistance. EMF, he gave us in the question, it's 5.76. The current, this is I total, it's 1.8. R capital is the external resistance, R over 3. R small is given 1.2. From this formula, we can get R. Now, distribute. So 5.76, 18 multiply R over 3, 18 divided by 3, which is 0.6 R plus 1.8 times 1.2, it's 2.16. Shift this to the other side. 5.76 minus 2.16 equal 0.6 R. Then we can get R from this. R equals 6 ohm. This is a little hard question. Yes? Question? Yes. Why did we say the currents in the same across? Yeah, because he said the same resistors. They say equal resistor. Equal resistance, it means that they have the same current. So they have the same voltage and the same current because they are equal resistance. Okay? I said because equal resistance, so the currents are the same in the whole circuit. Okay, now we go to next part. Talk about what? Talk about potential divider or potentiometer. This part is important. Let us solve this question. Start. Write one use of, okay, potentiometer. Comparing what? The potential difference. It's okay. So one use of the potential meter to compare the potential difference. So we write to compare the potential difference. Okay, now here find the reading of voltmeter. We need EY. What is the formula that we can use here? The formula in the potential here, we write EX, okay, or EY in the given here, EY over EX equals AC over AB. Now, we need to get AC. He said in the potentiometer, but he said here the wire is 100 centimeters. Then we can get the length of AC. So length of AC equals 100 minus 60 equals 40 centimeters. Then EY over, so EY over EX equals 40 over 100. Now, from this, EY, okay, it said the reading, so we need EY over EX, it's given, it's 24, equals 40 over 100. We do cross multiplication. So to get this EY, we do scissors cross multiplication. Then EY equals 40 multiply 24 over 100. The answer becomes 9.6 volt. Yes, question? Welcome, Mike. Welcome. Yeah. Mister, why did not you convert to meter? Oh, it will be the same answer. If you convert to meter, you will get the same answer. So this is 1 and the AC it will be 0.4. You will get the same answer. Next question. I give you the different questions about the potentiometer. Of course, one question will come in the exam about Kirchhoff's law. One question, of course, about the potentiometer. So it's a very important part, okay? Different. No, not 96. Okay, I will solve the same question, but in case of 1 meter. Look up. Okay, here. AC equals, we convert this to meter, so it is 0.6. And the AB, it's 1 meter. So AC, it's 1 minus 0.6 equals 0.4. Then EY over EX equals AC over AB. EY is the given over EX 24. AC is 0.4 over AB is just 1. Then EY will be 0.4 times 24. You will get the same answer. Okay? It will be 9.6. Okay? Maybe you forgot to convert 100 centimeter. It must be 1 meter. Okay? Okay? Did I reply? Now, next question here. Now, try to think of this, please. Yeah. We said here, this is comparing the potential difference. The figure 1 and 2 below show the circuits of the same potentiometer for comparison between E1 and E2. The balance points in each circuit is C and D. Okay? If the length of the resistance AB of the potentiometer is 100 centimeter, I advise you to leave it in centimeter to be easier. Now, we need to calculate AD. So AD equals 100 minus 31.5. So it's 100 minus 31.5. The answer is 68.5 centimeters. Now, E1 over E2 equals AC over AD. Now, from this, E1 it's 10 over E2 the required equals AC it's 58.3 over AD 68.5. Then we can get E2 it's 10 multiply 68.5 divided by 58.3. We use the calculator to get the answer. Yeah. Fraction 10 multiply 68.5 divided by 58.3. The answer here is 11.7 volt. 11.7 volt. Now, in question number 21, okay, what is the function? Now, the question is the same, but the answer is the same, but the question is different. What is the function of potentiometer comparing potential differences? Comparing, okay, potential differences. Now, that question is little hard. Try to think with me in that question. He said a battery has electromotive force 4 volts and internal resistance is 0.35. The battery is connected to uniform resistance wire XY. Now, XY here, we don't know the length of it. It is not 1 meter. And the fixed resistor of resistor R as shown. Wire XY has resistance. This is the total resistance of the wire. And the potential difference across XY is 1.8. Calculate the current. Yeah, start to solve it. Okay. It's easy, I think, this part. The current through XY equal the voltage through XY over the resistance of XY. We have the voltage. The voltage is given 1.8. And also we have the resistance 0.90. So the answer is 2 ampere. Finish this part. Okay. Next part. Okay. The number of 3 electrons pass through the point in the battery in 45 seconds. Oh, this question, it's easy. First, we find the Q. Q equals I times the T. The current from the battery, it's 2 ampere. This is the current through the whole circuit. It's 2 ampere. And the time is 45. So the answer is 90 coulomb. We need the number of 3 electrons. It's Q over E. Q, of course, in 45, which is 90, divided by 1.6 times the 10 power negative 19. The answer will be 5.63 multiply 10 to the power 20 electrons. Now we need the resistance R. Here, R. What are the givens for this? In the whole circuit, we have EMF in that part, 4 volt. And we have R small, 0.35. And we have the current, 2 ampere. And we need R. Okay, then we use the EMF formula. So EMF equals I multiply R capital plus R small. EMF is 4, I is 2. R capital, wait. R here, we have also R of XY, not only R. So R total here is R plus R of XY. R of XY is 0.90 ohm. Take care. Then it is R capital plus 0.9. This is R total here. R small is 0.35. From this, by using calculator, you will get R equals 0.75 ohms. This is R. Now, next part of the step. A cell of EMF 12 volt is connected to the circuit in part B as shown. Okay? Calculate the total length of XY. Now, how can we get the total length? Can we use the formula of potentiometer? Okay? X over E naught equals, for example, Y over AB? No. Why? Because we have here R external. So we can't use this one. Cannot be used direct. So how can we solve this? We find the voltage across XY. How? Okay. First of all, we find, okay, V across here, R. V across R, okay, V across this resistor R equals I multiply R. I, it's 2 multiply R here. I think it's given here, R. Okay. He said, let us we do here one by one. So the EMF in that one, EMF of the connected circuit. So this is, let us we do one by one. First, VXY, the voltage around XY. Okay, the voltage around XY. equals V total minus VR. How can we get VR? Okay, we need the terminal voltage. So E equals V capital plus IR small. Then the terminal voltage here outside, the terminal voltage equals E minus IR. E is 4, minus I is 2, and R 0.35. Then the terminal voltage is 3.3 volt. Now, V across this resistance here. Now, R already we got it before. This is R. So V according to this R, VR equals I, the current is 2, and the resistor 0.75. So the answer is 1.5 volt. Now, V around XY, it is the terminal voltage, which is 3.3, minus V across R, which is 1.5, which is 1.8 volt. Now, we use the formula that we have here, V, okay, 1.2, okay? So 1.2 here, this is the voltage, 1.2 over Vxy equals XB over XY. From this, 1.2 over 1.8 equals 0.3 over XY, the length. From this, XY will be 0.45 meter. Try to solve the same question again. It will be in front of you, but try to solve again, please, when you return back. I advise you to solve all the questions again. Now, in the last part, he said, the fixed resistor is replaced by a different fixed resistor of resistance greater than R. When R increases, the potential difference also will be increases around R. So the voltage around XY will be decreases. Then we have to shift it toward this Y. So we write as R increases because it's the same current, VR also increases. Why? Because V equals I times R, and I is constant, so V proportional directly to R. So V around XY will decrease. So we have to move. B is moved toward this Y. Okay, guys? Now, okay, we go to the multiple choice questions. Just I give you the answers, but I advise you first to solve the questions in your worksheet and then check the answers. Do not copy the answer direct, okay? Just I will inform you the answers of the multiple choice because they are very difficult. Okay, now, the answer of this question here. So the answer is part A. Okay. And now the answer of this part. If you have any doubt, you can inform me in WhatsApp. Okay. And here, the answer of this one here, it's here, part D. Number 25, the answer is part C. Okay, here. 26, the answer is part A. Last part, 27, the answer is A. Okay, still we have here. This is very important question, by the way, part C. By the way, all the multiple choice are very, very important questions and a little hard. So try, and if you have any doubt, I can solve with you. So the answer is A. Okay. Now, in this part about Kirchhoff, this is also very important part B. Okay. And now number 31. Here the answer is B. If you have any doubt in multiple choice, I will, explain to you. Last part here, this is also very important question. Take care, this will come in the final exam. But this is important, I guess. Okay, guys, now I send this file to you. After you send me your name in WhatsApp, please, in my WhatsApp. This is the WhatsApp, okay? So just send me your name in a message in that WhatsApp, and then I resend the file to you. I hope you understand this revision, okay? This revision, I said, contains higher level questions and the important questions from past paper. Next time we do revision 2, when I will send a message to you. Okay, guys? Yalla. See you next time. Yalla. Salam alaikum. Thank you. Thank you. Thank you.
Mr. Please.